Think of the classic Schrödinger's cat thought experiment. Until you open the box, the animal's quantum particles sit in a state of superposition, meaning the cat exists in multiple, contradictory states at the exact same time. If humans and planets are made of those same particles, we should theoretically also be trapped in an uncollapsed, blurry superposition. Yet our world feels distinct, solid, and singular. Physicist John Wheeler illustrated this discrepancy in 1970 using a U-shaped timeline. He proposed that the universe begins in a state of chaotic quantum possibilities, but it only solidifies into a single reality because something is watching it from the other side. Scientists call this process decoherence. It is the exact moment observation forces a system to abandon its infinite possibilities and collapse into one definite state. For our entire universe to remain stable and singular, we have to identify the ultimate observer, the mechanism constantly watching every particle to prevent it from slipping back into a blur. The rules of that observation are best seen in the double-slit experiment. When we fire a photon at a barrier, it naturally acts as a wave, moving through multiple paths simultaneously to create an interference pattern on the screen. However, placing a detector near those slits forces the photon to choose a single path. The act of recording that information breaks the superposition, and the photon hits the screen as a single definitive particle. In 2021, a new thought experiment scaled this up. Researchers asked what would happen if the observer, an alien named Bob, was watching this experiment through a telescope from a galaxy millions of light-years away. Even though Bob is seeing light from the distant past, the math shows his observation still forces the experiment to collapse into a particle state. In the quantum world, physical distance doesn't limit an observer's power. This implies that our local reality could be held in place by forces watching us from across the cosmos. To test the limits of this rule, we can imagine Bob watching our Earth-bound experiment from inside the event horizon of a black hole. This setup creates a direct conflict with Albert Einstein's theory of relativity. His laws state that an event horizon is an absolute barrier. No information can ever leave the gravitational pull of a black hole once it crosses the threshold. If Bob is trapped behind that horizon, the information from his observation should be physically unable to reach us, which theoretically means he shouldn't be able to collapse our quantum state on Earth. Yet the physics of decoherence suggests the state still collapses. It appears that the cosmic observation remains effective even when the observer is locked behind an impenetrable wall of gravity. A 2016 paper helped resolve this by introducing the concept of soft hair. Before a particle crosses the event horizon, its quantum information is recorded in the low-energy radiation surrounding the black hole. The event horizon acts as a permanent recording device. It captures the state of everything that falls into it, effectively serving as an observer that never lets the information go. These gravitational voids operate as massive ledgers of quantum data, maintaining a persistent record of the states they witness at their boundaries. This permanent recording process provides the mechanism for a stable reality. Research from 2023 suggests that because black holes are constantly cataloging the quantum states of the universe, they trigger a continuous chain reaction of decoherence. This prevents the particles of our macro world from ever remaining in superposition for long. This effect extends to the very edges of space. The 90 billion light-year boundary of our observable universe acts as another massive horizon, recording the state of every particle within it as the universe expands. If the universe weren't expanding, or if black holes didn't exist to record this data, there would be no cosmic witnesses to force a collapse. Matter would exist in a permanent, chaotic blur of every possible state at once. Our solid, singular world is the direct result of this universe-wide observation. Without these cosmic horizons acting as the final witnesses, the matter around us would dissolve back into the chaos of uncollapsed possibilities.